Welcome back. In the previous lectures, we were dealing with the reduction of expressions using K-map. So in the previous lectures, we have done with three-variable K-map as well as two-variable K-map. So we have done with pairs, quads as well as octets in the case of three-variable K-maps as well as two-variable K-maps. So in this lecture, we will be dealing with four-variable K-maps, how to reduce the given expression into SOP form, how to reduce the given expression into reduced SOP form and reduce the POS form using K-map. That is dealt in this lecture. Okay. So coming into the first question, realize the following expression using AOI logic. Okay. Realize the following minimize expression. Realize the following expression. Realize the following using AOI logic after minimization. So expression is f is equal to sigma m 23678 10 11 13 14 10 11 13 14. So this is in standard SOP form. This is in standard SOP form, or you can term it as in min-term form. It is in min-term form. So again you are having up to 14. So it is having dealt with a four-variable K-map. Dealt with the help of four-variable K-map. So first of all, draw the four-variable K-map. And drawing the four-variable K-map. So here we are having AB, CD. Yeah. So we are having 0 0 0 1 1 1 and 1 0. This is A bar, B bar, A bar, B, AB, AB bar. Again here also 0 0 0 1 1 1 and 1 0. Having C bar, D bar, C bar, D, CD, CD bar. 0 1 2 3 4 5 6 7 8 9 10 11 13 14 and 15. So now let me write the values of f. At 2 you have 1 2 3 6 and 7 2 3 6 7 8 10 11 13 and 14. Yeah. Okay. So these are the values what we are having. Okay. So how we can get the minimized expression? That is the question. First of all, you can take this quad. There is a quad here directly. Yeah. If you are taking the quad, what do you get? Here which is common, A bar is common. In these two terms, C is common. So you will get A bar, C. Again, here there is a quad. Yeah. So here what we can get, is here which is common, only CD bar. You will get CD bar. Again, to include this one, you can have a quad directly. These and these ones under quad. Okay. Because that two differs only by A and A bar differs only by 1 bit. Here also we are having only 1 bit difference. So here which is common? Here B bar is common. In these two C is common. So it is B bar C. Now to include this one, we can have a pair. Now coming to pairs. Green, you can go with to include this one. You can have a pair. So look at that pair. So AB bar is common and D bar is common. AB bar, D bar. But this is standing out, right? Yeah, so only this element is standing out. So you can write it as, okay, so you cannot pair to anything. Yeah? Yeah, because you cannot pair it to anything, you should take it separately. What is it? That is AB, C bar, D. AB, C bar, D. Therefore, the minimized expression we can write as F is equal to A bar C or C D bar or A B bar D bar or B bar C or A B C bar D. Yeah. Yeah. So that is the minimized SOP form of representation. Now, so rewrite it here. F is equal to A bar C. F is equal to A bar C or C D bar or C D bar or A B bar D bar or A B C bar D. A B C bar D. Now to realize the expression using AND or invert logic, okay, having A, B, C, D. So A bar is there, B bar is there, C bar is there, D bar is there. So you can have NOT gate. A bar, B bar, C bar, D bar. Yeah. First one is A bar, C. So C is here. So that is the first term, AND gate. So you get A bar C. Then next term is C D bar, right? C is here, D bar is here. So this is C D bar. Then next one is A B bar D bar. A is here. Now A B bar D bar. So you can have a 3 input AND gate. So A B bar D bar. Next one is A is there, B is coming in, A is there, B is there, C bar, A B C bar D. Take and distract. Yeah. So you get another AND gate here. And if you are ORing all these things, if you are ORing, this will be given to a 4 input OR gate. So that gives the expression F. Okay. So that is the basic AND or invert logic. Okay, so hope you have understood how to reduce the expression using K-map and how to realize the expression using AND or invert logic. So coming into second question. Reduce the expression F is equal to sigma m 0 1 2 3 5 7 0 1 2 3 5 7 8 9 10 12 13 8 9 10 12 13 and implement using NAND logic. Okay, So since here you are having up to variable 13, you should go with 4 variable K-map. Okay. So first of all, drawing a 4 variable K-map, and again these two is in min-term form. That is in min-term form. So you can draw a 4 variable K-map. One, two, three. So this is A, B, C, D. 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. So this is A bar, B bar, A bar, B, A, B, A, B bar. This is C bar, D bar, C bar, D, C, D, C, D bar. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So here, since it is in SOP form of representation, you should give the value as 1. That's 0, 1, 0, 1, 2, 3, 5, 7, 8, 9, 10, 12, and 13. Okay. So here you have the provision to take quads directly. So then we take the first quad. So first quad we can take like this. This is the first quad which I can take. So what is the corresponding expression? A bar is common, here which is common, D is common. So you get A bar, D. Second quad. Second quad which I can take is this one. So second quad. So here which is common, A is common. In these two terms, C bar is common. So you get A, C bar. And the last quad you can take from the four corners. Last quad you can take from like this. Take from the four corners. So now all the ones are taken in. So here what happens, in the first row and last row which is common, B bar is common. In the first column and last column which is common, D bar is common. So we get B bar, D bar. Okay. Therefore the most simplified expression is F is equal to A bar D or A C bar or B bar D bar. Okay. Now if you need to realize it using NAND logic, realization using NAND logic, F is given by A bar D or AC bar or B bar D bar. What is F bar? F bar is A bar D or AC bar or B bar D bar, the whole bar. What is it? That is A bar D bar dot AC bar dot B bar D bar, the whole bar. That is by the help of De Morgan's law. Okay. Therefore we can write F bar bar, that is equal to F, that is equal to A bar D bar dot AC bar dot B bar D bar, the whole bar. Okay. So that is basically the NAND logic. Okay. So you are having A bar, C bar and D bar. So you are having A, B, C and D. So A is there. Make a NAND gate with the two inputs are same. So you will get A bar. B bar should be there. B. So two input NAND gate with the same name. So we get B bar. Then C bar as well as D bar is there. So C This is C bar. D, you give a NAND gate, that is D bar. So first one is A bar, D whole bar. A bar is there. Yeah. So this is A bar, D the whole bar. Second one is A, C bar the whole bar. So C bar is here. Yeah. This A, C bar the whole bar. The last one is B bar, D bar the whole bar. B bar is here. Yeah. So D bar. So this is B bar, D bar the whole bar. And to get the result, you should NAND these three terms. So NANDing these three terms, you will get F. Okay. So this is the realization using only NAND gates. Okay. So this is implementation using NAND gates only. Okay. Hope you have understood the logic of reducing the expression using K-map. So here, so the specialty of K-map is that you get the most reduced expression. So coming into the third question. Reduce the following expression. Reduce the following expression and realize it using NOR logic. So question is given by F is equal to pi m F is equal to pi m 2, 8, 9, 10 2, 8, 9, 10 11, 12, 14 11, 12, 14. Okay. So this is basically in a POS form. Okay. And since you have up to 14, you can go with 4 variable K-map. Go with 4 variable K-map. So let me draw the 4 variable K-map. Yeah. 1, 2, 3, 1, 2. Yeah. So here you are having A, B, C, D. 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. A or B bar. A bar or B bar. A bar or B. Say C or D. C or D bar. C bar or D bar. Yeah, C bar or D. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Since this is in POS form, you should write values of ones. So 2 values of 0. So at 2 you will get 0. At 8 you will get 0. At 9 you will get 0. At 10 0. 11 0. 12 0. And 14 you will get 0. So here you can go with pairs and quads. So if you are going with the quad, first you will get quad here. This forms a quad. So what is it? So you will get A bar or B. Then these two can be paired. So if these two are paired, here what we get? If that two are paired, what we get is here common is A bar. Here so it is A bar or C or D. Again you can pair these two. Okay. So if you are pairing that two, what you get? A bar or C bar or D. And the last pair you can form like this. You can form pairs these two. can be paired. So pairing that to what you get, which is common here. Here B is common, and here B or C bar or D, that is common there. Okay. So if you are writing the expression, if you are writing the minimized expression, you will get it as F is equal to A bar or B and A bar or C or D and A bar or C bar or D and B or C bar or D. Yeah. So that is a minimized expression. Oh, wait, please wait a minute. See here, there is one mistake what happened. You can take one more quad here. Okay, you can take a quad. These two forms a quad. Okay, so taking the quad here, which is common, A bar is common. In these two terms, which is common, D is common. So it is A bar or D. Okay, so you can take it quad. That is it. So here you are getting only three terms. So that is the most minimized expression. That is F is equal to A bar or B, A bar or B and A bar or D and B or C bar or D. Okay, that is the most minimized expression. Okay, sorry for the mistake. So we can write F is equal to what? F is equal to A bar or B and A bar or D, A bar or D and B or C bar or D, B or C bar or D. So to realize the NOR logic, okay, what is F bar? F bar is A bar or B and A bar or D and B or C bar or D, the whole bar. Then you can write it as A bar or B whole bar or A bar or D the whole bar or B or C bar or D the whole bar. Therefore F, you can write it as F bar bar, that is equal to A bar or B bar or A bar or D bar or B or C bar or D bar the whole bar. So this is basically in NOR form. So here you are having A bar or B. So I am taking A bar as input, B, giving it to a NOR gate, Okay, so you get A bar or B the whole bar. Second one is A bar or D. A bar is here. This is A bar or D the whole bar. Last one is B or C bar or D. So this B, D or C bar, that is given to NOR gate, and these three inputs are given to a NOR gate. These three inputs are given to a NOR gate. So here you will get F. Okay. So that is the basic realization based on this NOR form. So here I have taken A bar and C bar as input. A bar, B and D are the four inputs. Okay. So instead of A, I can take A bar directly. That is also possible in the form of digital circuits. Okay. So I think you have understood how to reduce the given expression using K-map. Okay. And how to generate an AND or invert logic, as well as NAND logic, as well as NOR logic using this K-map. Okay, so the major advantage of using K-map is you will get the minimized expression. So in the next lecture we will deal with some definitions related to K-map, and after that we will go with the don't care combinations. Thank you.